So I want to go over this test review, which is a pretty standard test review for a first test in a college algebra course. Alright, and so I have several questions I want to look at. Firstly, let's simplify here the square root of 12x to the fifth y to the fourth. And so the way we do this is I'm going to factor what's under the square root, and anything that can show up twice I can take out. So I could write it like this. I could write 12 as 3 times 4. Instead of writing x to the fifth, I can write x to the fourth times x, and then leave the y to the fourth by itself. And the reason I did this, firstly, one, we have a property that x to the m plus n is the same as x to the m times x to the n. That's why I could break up x to the fifth like this. Okay, now why did I do that though? Is because I recognize that 4 here is 2 times 2. I recognize that x to the fourth is x squared times x squared, and y to the fourth is y squared times y squared. So from that, I can take out a 2, x squared, y squared, and I'm left with the square root of 3 times x, or we'll just say 3x. Okay, so there's my solution. There it is simplified. Alright, now secondly, I want to evaluate this expression for x equals -1, and so that means all I have to do is replace x with -1. So I have 3 times -1 squared minus 4 times -1 plus 1. And so I just need to be careful with my arithmetic here, but I know that -1 squared is 1, so I have 3 times 1. And I know that -4 times -1 is a positive 4, and then I have a plus 1. So 3 times 1 plus 4 plus 1 is 7 plus 1, which is 8. Okay, next I want to simplify this expression, -2x quantity squared x to the -4th y squared over 8y to the negative cubed z squared. And this looks complicated. First thing I want to do is I want to square this -2x squared term. So I get 4x squared x to the -4th y squared all over 8 y to the negative cubed z squared. And first thing I want to do, or the next thing I want to do, is recognize that this cancels to give me a 2 in the denominator, or a 1/2. And so what I'm going to do is I recommend that you bring everything to the numerator. And the way I can do this is a property. So here's a second exponent property. 1 over x to the n is same as x to the -n power. So anything that's in the denominator can be sent up to the numerator, and just multiply the power by -1. And so that's what I recommend you do. I recommend you take all the variables and get them into the numerator. So I have 1/2 x squared, x to the -4th, y squared, y to the, okay, I want to take this negative cube, I want to bring it up to the numerator, so I multiply its power by -1. It gives me y to the positive 3 power, and then z to the -2 power. Okay, so if you can't see it, this is my denominator here. Alright, from there, I can, just like we learned in property 1, right here, I can add my exponents. So I have 1/2, adding the exponents to get x to the -2. I have y to the 5th power, and z to the -2. And so lastly, if I want to bring those, using this property, bring them back into the denominator, I have y to the 5th in the numerator. In the denominator, I have 2x squared z squared. And there it is. If you think back to the first one, we had the square roots. The reason I could take out this 4, for example, is because I recognize that was 2 times 2. With a cube root, I can do the same thing, but everything needs to show up 3 times. Okay, so I need to try to factor this thing. I know that this is the cube root of, let's see, let's do -1. And let's say 24 can break up as 8 times 3. And now I need to think in terms of 3, so x, how about taking out x to the 6th times x, and then y to the 5th I can say is y cubed times y squared. Okay, now the reason I did that is because this is something showing up 3 times. That's x squared times x squared, and the y cubed is obviously something cubed as well. And the 8 I know is 2 times 2 times 2, and actually the -1 is -1 times itself 3 times. Okay, so the -1 is a cube as well. So here that means I can take out a -1, a 2, x squared, y. And when I do that, I'm left with what's inside. I'm left with the 3x y squared. And so there's what's inside, and there it is. It's simplified now. Okay, now we're going to move on to some factoring, and we have several techniques to factor. And some of these, if you remember the strategy, you need to first look for greatest common factor. So let's see, I'm going to write here. You have greatest common factor. If that doesn't work, try grouping. Okay, if that doesn't work, you can try looking at your binomials, your special binomials. And then lastly, we have trinomials, trinomial techniques. Okay, so we're going to look at these and try to factor them like that. The first one I recognize instantly, that's a binomial. And so I remember that for the binomials, I have a few. I have a squared minus b squared is the same as a minus b times a plus b. I know that a cubed minus b cubed is a minus b times a squared plus 2ab plus b squared. And I know that a cubed plus b cubed is a plus b, a squared minus 2ab plus b squared. That's a lot of stuff, but it's just memorization, okay? And so what I recognize here for this first one is I have an a squared minus b squared situation. And so this is just going to factor as a minus b times a plus b. So there it is. It's factored. Okay, the second one I instantly recognize is a trinomial. So I can factor it in this way. I need to think of two things that multiply to give me -6 and add to give me -5. So it may take you a little while. You might think, how about 3 and -2? That adds up to give me 1. Okay, but after a while you'll realize -6 and 1 works. They multiply to give me -6 and add to give me -5. So then I can factor this as x minus 6 times x plus 1. And there it is. And if you doubt yourself, just double check. Make sure you did it correctly. Alright, the third one, or number 7 here, notice that we have 4 terms. So instantly I know I'm either going to do greatest common factor or grouping. And I can look and see that these terms have no greatest common factor. So I'm going to try a grouping method. I'm going to group my first two, which I notice in my first group I can take out an x. And if I do that, I'm left with an x plus 3y. Out of the second group, I can't really take out anything, but let me say I'm going to take out a 1. And when I do that, I'm left with 3y plus x, which is another way of saying x plus 3y, correct? Alright, so now notice I have two terms, and they have a common factor, this x plus 3y. So I'm going to factor out the x plus 3y. And when I take it out of my first group, I'm just left with an x. And when I take it out of my second group, I'm left with a 1. And there it is. It's factored. And that's the grouping method. Okay, number 8. So for number 8, we want to try factor by grouping, or I'm sorry, greatest common factor. And I've noticed that because in each term, I have a 3, and I also have a y cubed. So if I take a 3y cubed out of everything, notice in my first term, that'll be just the 2x. In my second term, I've taken out all my y's, and I'm left with a 3. And in my third term, I've taken out the 3, so I'm left with a -4x, and I have 1 y left over. And notice what I'm left with in the parentheses cannot be factored. So there it is, factored completely. Alright, now moving on to number 9. I notice I have an x cubed minus 27y cubed. So going over here, that's a binomial. That's going to be a cubed minus b cubed situation. Okay? So you have to recognize that x is a here, and my b is, what's the cube root of 27? It's 3y. Okay, so this is going to factor as a minus b, so that's x minus 3y, times a squared, which would be x squared, plus ab, which is 3xy, plus b squared, which is a 9y squared. And there it is. There's my factoring. Alright, so that's 5 different factoring examples. Actually, yeah, 5 factoring examples, and I hope those make sense. Okay, now let's go on to number 10. Here I'm going to do some absolute value stuff, and you have to remember the absolute value of x is x for x greater than or equal to 0, and negative x if you're less than 0. If you plug in a negative value to absolute value, you're actually multiplying that again by negative 1, resulting in a positive. So when I'm trying to simplify negative negative 9, this is the same as negative, well, okay, this is the same as negative 9. And there it is. I'm done, actually. Okay, so that's not too bad. But when I look at number 11, and I want to determine the absolute value for x plus 2, given x is greater than 5, this means here, I got to consider this definition. Does x greater than 5 make this thing positive or negative? Because that will change the result when I drop the absolute value. Okay, so, but if you think about it, anything greater than 5 plus 2 is going to result in a positive. So for x greater than 5, the absolute value of x plus 2 is simply just the same as x plus 2. You can just drop the absolute values. If they change the question here where it said something like this, so I'm going to change the question. Let's say given x is less than negative 3. Okay, and so if that's the case, then when I want to drop the absolute values, well, notice if I plug in negative 3 or anything smaller than that, the inside is going to be negative. So to drop the absolute value, I need to multiply again by negative 1, and that's consistent with this definition here. Okay, let's get into some complex numbers. So we have to remember that I stands for the square root of negative 1. So if I square I end up with negative 1, and that's the power of I, and that's why it's so important. And that's something that we need to be very familiar with, okay? Now, by chance, if I cubed I, then I get negative 1 times I, which ends up being negative I. And if I raise I to the 4th power, well, that's the same as I squared, which would be negative 1 squared, which gives me 1. Okay, so that means if I go back to the 5th power, well, the 5th power ends up being I again. So here, I to the 5th, I to the, let's see, 8 plus 1 is 9, and so on, will always be the same value, it'll be 1. I'm sorry, I. Okay, so if I'm trying to evaluate something like I to the 29th, here's what you do. All you have to do is divide 29 by 4. And so I know that 4 goes into 29 7 times, which is 28. It gives me a remainder of 1. The remainder tells you what your answer is going to be, because I to the 29th is the same as I to the 1st power, which ends up being I. Okay, so if you got I to like the 311th power, okay, all you do is divide 311 by 4. So let's see, I know that's going to go in 8 times. Oh, I'm sorry. It's going to go in 7 times. It's 28. Okay, so you get 3, 1. So that's going to be 77 times with a remainder of 3. So the remainder again tells me that I to the 311 power is the same as I cubed, which is, according to what we did here, negative I. So that would be my answer. Okay, so the remainder tells you, according to this chart here, the remainder tells you what this is going to simplify to. Okay, now number 13, we're trying to simplify the square root of negative 144. And this is pretty simple because I know that the square root of 144 is 12, and the square root of negative 1 is I.